This new derived methodology will improve the product reliability. I will provide 2 case of study. This is automobile. The automobile consists of multiple modules and the engine, transmission, driver, electric system. And the total components at 20,000 pieces. Life target is at between 10 years. To improve the performance of the reduced cost product, will be designed every year. By reliable testing and the engineering should be find the design fault and the product, the module. This is airplane. It also consists of the multiple of the module, motion system and door, aviation control, etc. Total component 200,000 pieces. Life target is between 10 years. This is a refrigerator. It consists of the multiple module and the cabinet, door, and internal fixed, etc. Total component 2,000 pieces. Life target is between 10 years. This is a definition of the reliability, and it can express as ability of the item and the performance the required function under the state, environment, and operating condition, or the specified period of time. And therefore, the U product, the reliability can be described in the best terms. And but if your product follow the best term, it will be rejected from the marketplace because of the high initial failure rate, higher failure rate, and the short lifetime. So, and the companies improve the product design and best will be the changing in the straight line. And finally, we can recognize that the product is reliability can be achieved without design failure. This slide shows the failure mechanism in the product design. And if a product is the repeated load is subject to the product structure, there are design flaw, and the structure will collapse and in lifetime. To prevent it, and the design flaws must be found before the product launches. The issue, how to find them, and the solution is reliable testing of the XLive testing. This slide shows the solid state of diffusion and impurity in silicon. And it takes place as a following process: electron migration induced voiding, buildup and the chloride ion, traffic by and electric and holes. If I take the electric field, and the barrier will be distorted and shift, and the junction function will be described in the function of the cyanide fabric and the temperature. This is a junction function of the in silicon. If I take the inverse, we can find the general stress model. As you can see the slide, and the cyanide fabric is started to the linear and power stress and exponential. Most of the accelerated testing is carried out in the medium range. Time to failure is simply and the power of the stress and the temperature. And finally, we can find as accelerated testing is the ratio of the stress, and we can find the temperature difference. This is the power is a multi-photo system. Power is can define as a product of the effort and the flow. For example, and mechanical translation, effort is a force, flow is a velocity. This is a time to failure, and the stress comes from the effort. And then you can modify, and the accelerate factor is a ratio of the effort and the temperature difference. I will explain how to derive the sample size equation. Product follow the Weber distribution. The derived function is defined as a function of the characteristic life and the shape function. If you take the logarithm, we can find the dx life. The problem, how to find the characteristic life, we can find the testing data. And then we can just summarizing and assess the dx life is a function of the chi-scale and logarithming and the testing data. I will explain how to find the sample size equation from the approximate dx life. As you can see the slide, there are two approximations. One is a chi-scale approximation, another is a logarithmic approximation. And if I follow the chi-square approximation and the complex rate 60%, R is less for them. The chi-square is at R plus 1. And the logarithm is at the cumulative failure rate less than 20%. And follow the X. We arrange the pixel life. We compile the sample size equation. And I will give you one case of study. This is the refrigerator, and this is a compressor with modify and modify a crankshaft. And it consists of a lot of parts. And there are design port in the URI design compressor, but we don't know that which part is a design port. And the compressor lifetime depends on the parametric part, and to find them and require the new reliability methodology. This is a parametric design and schematics, and as you can see the slide, and the compressor is the increased pressure and from low and high pressure. We don't know how to use the custom usage condition, and we have to design and each part. And the reliability methodology consists of 3 parts. One is failure analysis, parametric art, and with design modification, finally checking, and product as a lifetime target. This is a damaged product in field, and we found a lot of the wear, and this is came from the lubrication problem in field. And to modify, and it required the parametric art and collect them. This is a load analysis, and this is the vapor compression refrigerator cycle, and from the conservation of the mass in capillary tube, energy balance in the condenser and the evaporator, we can determine the mass flow and evaporate temperature and the condensing temperature. And at the summarizing, and we can find the stress come from the pressure difference. I will explain how to calculate of the accelerator factor. Accelerator factor is dependent on the pressure difference and temperature difference. I will tell you and how to calculate the pressure accelerator factor. For worst of case, pressure difference is 1.7. We apply the accelerator load in the 1.96. We assume that lambda is 2. We can calculate the accelerator factor is 3.4. Temperature is I will tell you and how to calculate temperature acceleration. Room temperature is the 19 for worst of case. For acceleration, we apply the 120. We can calculate accelerator factor is 1.4. We can find that the total accelerator factor is 4.6. By applying the duty cycle of the compressor, we can search and design port. I will explain how to calculate the mission cycle. The life target is the domestic compressor is beyond life 10 years, and the accelerator factor is 4.6. Total sample size is 100. Compressor lifetime is for 10 years, 87 and 1,000 cycle. There is no problem 90,000 cycle, and we can guarantee the compressor lifetime beyond life 10 years. This is equipment used in external light testing. They are consist of a test jig and the schematic and the schematic the diagram. We can proceed the parametric art with the equipment. I will tell the result of the first parameter art result. And we found the compressor lock and due to the lubrication and at the 7,000 and the 10,000 cycle. As you can see the slide, the pattern of the in the field and very identical in the first art. And then by parameter art, we can reproduce compressor failure in field. I will tell you the root cause of the combustor wear. There are three root causes. One is lubrication of the area. Second is low starting RPM and the material. And as an action plan, we design a crankshaft. And then one is we relocating and the hole size and the changing in the dimension and the changing in the material. And adding in the U grooves. By parameter art, we can collect and compress failure. This is the second result of the parameter art, and we found the crankshaft wear at the 19,000 cycle. The root cause came from the interference between the crankshaft and the thrust washer because of narrow clearance. We changing in the dimension and from the 1.1 from the 1.4. We by parameter art we can modify the design port of the compressor. This is a summary of the parameter art, and we first the parameter art we found the lubrication problem of the crankshaft. And we changing in the material and changing the dimension groove and redesign the crankshaft and changing initial RPM. In the second art, we found another crankshaft wear. And as an action plan, we increased the clearance between the washer and the crankshaft. Finally, and in the third art, there is no problem. And 90,000 cycle and 20,000 cycle. And the compressor achieved the lifetime, the pure life 10 years. I will give you another case of study. This is a refrigerator in another assembling hinge kit system. Hinge kit system is consists of there are a lot of parts. One is a hinge cover, oil damp, and the housing. There are design port in the hinge kit system. We don't know which part are. Hinge kit system lifetime depends on the design port of the part. To find them, it requires the new reliable methodology. This is a parametric design schematic. Hinge kit system is designed to the close the door gently. And when we don't know how to use a custom used condition, and we have to design and each part and optimize it. And each of the methodology consists of three parts: and the failure analysis, the parameter art, and with the design modification. Finally, and the checking and the lifetime targeting. And this is the damage of the product in field. We found that a lot of the crack on the hinge kit housing, and It came from the fragile types, and by reproducing and parametric art, we can collect them. This is a load analysis of the accelerated testing, and normally Hinge key system is subject to the door weighting only. To increase the impact, we added to the additional weight. The time to failure depend on the moment and the impact. By control the impact, we can carry out and accelerated testing. I will explain how to calculate the accelerated factor. And for worst of case, the load is 1.1. For accelerated testing and 2.7. Lambda is 2, and we can calculate the accelerated factor is 6.7. By applying a duty cycle and the Hinge key system, we can search out the design failure. I will explain how to calculate the mission cycle. Lifetime N is a Hinge key system beyond life 10 years. Accelerated factor is 6.3, and the total sample size is 6. Indicated the lifetime is 10 years and 36,000 cycle. There is no problem in the 41,000 cycle, and we can guarantee the lifetime target is a Hinge key system beyond life 10 years. This is the equipment for the accelerated testing, and we have a test jig and a controller. We can proceed the parametric art with the equipment. I will explain the result of the first parametric art. We found that the Hinge kit housing crack and at the 3,000 and the 50,000 cycle. There are various, the pattern of the first parametric art is similar to the data of the field. By parametric art, we can reproduce the design port of the Hinge kit system. I will explain how to improve the project structure of the design Hinge kit system. Because of the Hinge kit failure in the first parametric art is came from the project structure. We reinforced the structure of the Hinge kit system in the outside, and the Hinge kit system we eliminated the notch and gave it to the round. And we also gave it to round inside. We also gave it to the reinforced the rib and on the housing and the decks. In the second art, in the first art, we assembled the Hinge kit system. At that time, we found the leaked oil. The root cause came from a PARAMETRIC as an oil damper sealing structure for the impact loading. When I operating and operating and the damper of the Hinge kit system, both the oiling and interferes with the Teflon, and finally oiling and the tear and the damper is the leaks. And therefore, we modify and the sealing and the structure. And by parameter, we can reproduce the port of the oil damper. I will explain the second result of the parameter art. And the housing cover is Hinge kit system crack and the 7 and the 9,000 cycle. The root cause of the material of the housing cover. When an operating and Hinge kit system, all dampers spot and strike housing cover. Finally, and the housing cover is cracked. As an action plan, we modify and the housing of the hinge cover material from the plastic and the aluminum die casting. By parametric art, we can modify and the fragile housing cover the hinge kit system. This is a summary of the parametric art, and in the first art we found in the project and the housing and oil damper, and then we modify and the design of the housing and the oil damper. In second art we found in the crack of the housing cover, we modify and the material and uh, and and changing the material and from plastic and aluminum die casting. In third art, there is no problem, and we can guarantee the beyond like 10 years. This is my paper, and submit to the Reliable Engineering and System Safety, entitled Reliable Design of a Case Study, and the Domestic